And that's where people will say, hey, well, that's what the data lake's for. Like, yeah. The issue is who's going to know and understand the data as it arrives at the data lake. Who works in the enterprise level of that historical archive? Probably not your level 2, level 3 plant folks, right? Not your OT teams, but your IT teams. And so how do we make sure that those working at the data lake have the knowledge of the process encoded into the information that arrives there? That's the challenge.
That's interesting.
And so what that drives is essentially, it means we need to be building models at the edge. We need our operations teams to have the ability to tell us what the data means. And of course, the problem is no one at operations is going to just do that to do it. The only way that you're going to get a bunch of engineers whose focus is to improve quality, reduce downtime, make the number of widgets according to plan, the only way that you're going to get them to model data is to make it necessary for them to do the job they're already been tasked to do, to make their life easier. And this is the thing that when we started talking about this architecture 3 years ago, this wasn't just me and Graham talking. This was talking to really bright men and women outside of Flow Software. And this is, hey, Walker, how do we solve this? Arlen, how do we solve this? It's a much bigger conversation. Alan Ray, like where are our gaps here? Ryan Crownover over at Vertec, what are we missing in these architectures? And we all kind of came to the same conclusion that we needed a way to take the maintenance, the inventory, the quality, and the production systems of a plant, and the 3 or 4 or 5 different databases that are inside of each of those, and the subject matter expertise that's inside of each of those parts of operation. And we needed to put a layer on top that was where all of those engineering teams were building the model that the plant runs off of. Because at the end of the day, that Power BI report, it really just is taking the exact same information the engineers need, and it's just changing the amount of time that you're focused on. The engineers are looking at minutes and hours, right? And shifts. The BI team, the business team, is looking at quarters, and they're looking at 90-day projections. And so it's not a different metric. In fact, my argument would be that if you don't do it this way, you can't trust the KPI. You can't trust that the way that a production KPI is built over in the data lake matches the same way a production KPI has been built and defined at the edge. It'll never be the exact same if you let 2 different people build it. The engineer at the edge on a utility consumption is going to understand enough context about the raw data that they're going to write data cleansing rules that are going to nullify water flow when the valve is closed. That normally might have some very small little echoing on the sensor, right? Some bad feedback on the sensor. That's probably not going to be a known thing on the data lake side, because the engineer on the data lake doesn't understand the valve to flow relationship on that process flow or in that product flow. So you've got to define how these KPIs are being cleansed, how they're being aggregated, how they're being expressed somewhere. It only makes sense to do it at the site, and then persist that information as context as it then goes to the UNS, as it then goes to the data lake, so it can then drive the Power BI report or the cloud-focused ML project. What we're seeing, though, is that really that data lake as a long-term strategy is more about the business layer than it is AI or ML. Those AI and ML models are going to get pushed to the edge every time. That's where they're going to live. So they're going to live at operations. That's also then where I need to have this architecture that supports that, that allows them to make queries into all of those different databases inside of all of those different systems, my maintenance, inventory, quality, and production systems. They need to be able to access the rich history on demand from those systems, because they're looking for needles in haystacks when they're doing these types of advanced analytics. They need to understand how to interact with those systems. They need to understand the context of those systems. They need to understand what type of results they should expect or shouldn't expect when they interact with those systems. And that's what's so important about right now and building an architecture that allows for that.